Managing a fleet of deployed IoT devices is chaotic. When hardware runs hot or memory leaks occur, engineers have to manually parse logs and push firmware updates. If they make a mistake, the device bricks. Welcome to the Embedded Fleet Configurator. This project uses the Agent Development Kit, ADK, to build a multi-agent system that autonomously analyzes telemetry and optimizes firmware, but with a strict, deterministic safety guardrail. The system uses 3 agents: a telemetry parser, a firmware engineer, and a security validator. To keep the system secure, I built a custom model context protocol, or MCP server. Instead of giving the agents open terminal access, the MCP server acts as a secure bridge. It only allows the agents to read local sensor logs and write specific header files. Let's watch the agents in action. I am running the pipeline on a simulated ESP32 device experiencing thermal issues. First, the telemetry parser ingests the raw MCP data and flags the heat spike. Next, the firmware engineer proposes a fix by increasing the deep sleep interval. However, it hallucinates. It tries to allocate 1024 kilobytes of memory to a chip that only has 512 kilobytes. If this code deployed, the device would crash. But look at the terminal. Before the MCP server writes the file, the security validator intercepts the payload. It runs a custom bounds checking skill, detects the hardware limit violation, and immediately halts the pipeline. The bad code is blocked. By separating generative problem solving from strict boundary validation, this architecture proves we can safely automate hardware engineering. The codebase is fully open source. Thank you to Google and Kaggle for an incredible intensive vibe coding course.